Hello dear students. In the today's video class, we are going to talk about the Aldol condensation. Aldol condensation reaction is one of the important property of aldehyde and ketone. The aldehydes and ketones with alpha hydrogen, you just see with the alpha hydrogen can undergo this reaction. What are the best examples? These are the examples. You consider CH3CH4. The compound is called as acetaldehyde, in which the carbon next to the functional group is alpha carbon. It has got 3 hydrogen. These 3 hydrogens are alpha hydrogens. So due to the presence of alpha hydrogen, this can answer for this aldol condensation. This can undergo the aldol condensation reaction. Likewise, if you take acetone with the following formula, this can also undergo the aldol condensation because this is a functional group of ketone. On either side, we are finding 2 alpha carbon atoms. So there are some alpha hydrogens present in it, and hence this can answer for aldol condensation reaction. Consider the following aldehyde called formaldehyde. It's an aldehyde called formaldehyde, in which the functional group is present. There is no alpha carbon, and hence there is no alpha hydrogen. So without alpha hydrogen, this formaldehyde do not undergo aldol condensation. If you take benzaldehyde, it's a formula for benzaldehyde. We know the structure for benzene. So this is the structural formula for benzaldehyde. The carbon bonded with CH4, this carbon is alpha carbon, and there is no hydrogen, and hence the benzaldehyde do not undergo this reaction. So the aldehydes and ketones having the alpha hydrogen can undergo this reaction. I am taking an example of acetaldehyde, step 1, in which the acetaldehyde is taken, CH2CH4, conveniently one of the alpha hydrogen is taken outside. When this is treated with the sodium hydroxide NaOH, NaOH will be dissociated to form Na plus and OH minus. This OH minus is the nucleophile. That OH minus can abstract this alpha hydrogen. This is called alpha hydrogen abstraction, which means the alpha hydrogen removal. Once the hydrogen is removed as H plus, the bonded electrons are carried by the carbon, so that the carbon can carry minus sign. You can have CH2CH4, the carbon carries minus, plus H2O. The carbanion is formed here. Dasmered carbanion can behave like a nucleophile. Yes, this is a nucleophile which is generated in step number 1. Consecutively, in the step 2, in the subsequent stage, take a fresh molecule of acetaldehyde having this formula, and that should be treated with CH2CH4. The carbon carries minus. There are few steps. Attack of nucleophile on the carbon, the nearby bond breaks up. We know that in the carbonyl group, oxygen is most electronegative, hence it is carrying minus. The carbon is carrying plus. The carbon plus is attacked by the CH2CH4. At the end of this step, we can have a product as follows: CH3CH. It becomes O minus. Here you have added CH2CH4. Now, in the last step, in the third step, step 3, You write this in the reactant side, CH3CH O minus CH2CHO. This on protonation, on treatment with the acid, oxygen is providing electron back to the hydrogen, so protonation takes place and this is converted into OH. So we can have a neutralized product as follows. Yes, this is the substance merd. The compound thus merd is called as aldol. And how to write the IUPAC name of this aldol? Try to count the number of carbon atom in a long linear chain. There are 4 carbon. So the parental source is butane. You can call this as butanediol. There is a hydroxy group in 3rd position and hence it would be called 3-hydroxybutadiol. That is the IUPAC name of this aldol. Finally, the aldol thus obtained CH3, CH, OH and CH, on heating subsequently in the last stage. What we are obtaining here is written in another format. CH3, CH, OH is there, CH2, CHO. I have taken one of the hydrogen outside, CH2, it is being written as CHH, CHO. In the heating or while heating the substance, there is a chance of getting water molecule. The hydrogen is leaving as H plus and subsequently OH is removed as OH minus. So there will be double bond in between these two. That results to the formation of CH3CH, double bond CH, single bond CHO. It is an unsaturated aldehyde. Its name is crotonaldehyde. So this is the final product obtained on heating the aldol. We are getting the crotonaldehyde. How do you give the IUPAC name of this compound? So this is 1, 2, 3, 4. There are 4 carbon in the linear chain. So it is to be called butene. But the double bond is present at the 2nd position, so that I can call this as but2ene. The aldehyde is the function, the last letter E is to be replaced by Al. But2ene all, that's the IUPAC name of this crotonaldehyde. So the aldol condensation reaction is explained with the help of acetaldehyde. The same can be explained by using the acetone. And when you mix up acetone and acetaldehyde, that can be called as cross-aldol condensation. That we are going to discuss in the next class. So thanks for watching. Try to watch this kind of videos continuously and try to support us. Thank you.